This is just a short video. It's about the project, the school competition that was run a few years back, called Formula Schools. And there's various classes. The basic class was really building a scratch-built bodywork and chassis for the Mardave Ministock. If you're not familiar with the Mardave Ministock, this is a built-up car here. It's got a few differences on it, and I've got a basic chassis here. This design is really simple. It's really quite an elegant idea. The concept is brilliant because you can really just machine out all these parts just on a CNC router. You can even make a lot of the parts by hand. There's various improvements and developments by different manufacturers over the years. On this example here, I'm using the wheels are actually Hunter Systems. They're based on I think it's the 1970s design, the original Mardave Ministock pattern. Super easy to build, very few parts, no suspension on this at all. It really gets just a little bit of suspension through the chassis flex from the fiberglass reinforced plastic. So it's yeah, really nice little concept. The axle is just a little piece of 1/4 inch diameter steel rod. Then the wheels and the gears are actually moulded in one part. Still available from, possibly limited in numbers, are still available from Mardave. Bumpers can be CNC routed, or you can make a pattern and you could just route those out with a handheld router and use a jig just to drill the holes. The original Mardave, this isn't an original one, I think it's a Manic Mini sold by a company called Camtech. But the original Mini had an aluminium plate chassis, and the bumpers had little mounting plates which are bent up from sheet aluminium. So you could go that way as well, but this is quite nice because you're using routed parts, or CNC routed, or cut by hand. The front end is really simple as well. It's just an injection molded piece, single piece, and then you've got your steering arms there, and then your little ball joints which you'd have to buy in. The wheels could also be 3D printed. It's possible you might be able to even mold the tyres out of silicone rubber in a mold, or you could use some of the softer 3D printing materials, but I don't have experience of doing that. But then if you can really get the price down by just buying in materials and making them at a cost price in school, I think that's a really nice way to get a really interesting project available for the students. It's ideal as a sort of design technology after school or lunchtime club, and this is a really nice base, and then students can develop their own designs. The little servo mounts, I just routed those on a router just with a little slot drill. Drilled and tapped those, so M3 nuts and bolts just screws through. The battery tray, I made a pattern on a CNC router so that can be vacuum formed. This one's actually the Camtech one. I built or purchased the Camtech just to get the ideas, get the patterns for the beds so the students could manufacture those in-house in the school. So yeah, that's a basic running gear. There's ball bearings on the rear end. The wheels just hold on with a kind of grub screw. So you could even make the wheels on a manual lathe. That would be nice to do a bit of gear hobbing as well. So you could even use a sort of single point sort of gear cutter and a dividing head, or a sort of fourth axis on a CNC mill, which would be fun. Or I could even just do it by hand, just using the gear to index, and then just have the single point tool just to cut the gears. So yeah, really nice base, and then you've got the body posts which are just turned on a lathe just out of 6mm acetal rod. So that's the basic chassis, and that's the same chassis as this finished one. And I've just masked the roof, sprayed the whole car white, masked the roof, and then sprayed it with a kind of metallic British racing green colour. So it's got the Tamiya body clips on there to hold it on, and then I vinyl cut these on the school vinyl cutter. So you've got the Union Jack on the roof, and then you've got different sponsors logos as well. So Camtech, this was based on a sort of 1960s mini rally car, just with the numbering on there. I've actually got the Hunter Systems on there as well, but Hunter Systems have ceased trading, so this kind of dates the when I'm actually first ran this project in the school. What's quite nice, you can buy the little hop-up parts and anodized wheel nuts and things and really make them quite personalized. You can spend a little bit of money or just keep things cheap and just keep it stock. But you can just buy a pack of M3 nylon nuts and just very bolts and things. I haven't actually worked out what the bolt lengths are, but most are sort of 10 to 12 millimeters, and then you just need a few longer ones just for the front axle and things like that. So on this one, I've got a carbon fibre chassis. I think that's probably actually a negative to its handling because it's much more rigid, so there isn't the chassis flex as in with the fiberglass. And this one, I think I've got a Tamiya Sport Tune motor. I've just ordered a number of pinion gears from AliExpress. I think they were £4.50 for 11 to 17 millimeters, so it gives you that little bit of kind of testing and tuning as well, so you can see what sort of gear ratios work best with different tracks and get your lap times and things that way. So that's the basic one. What I've got is slightly different on here. I think I've got the rear axle is from the current Mardave Ministock, which is based on a short wheelbase V12 chassis. So that's quite nice because you can fit differentials and things. And on this one, I thought it was quite fun. It's got the larger wheels on the back and smaller wheels on the front, which just gives it a bit of sense. I had to raise the body shell up, so it's higher at the back, lower at the front. Just looks fun. I kind of like it. So that's the finished one. And as I said, that's the basic version of the original Mardave, really. So this chassis is a development of the one I've just shown you, just so it's without the bodywork. You can see I've got the rear body posts on here, carbon fibre, little upstand for the body mounts on the back, 6mm acetal for the body posts. Got a little heatsink on here. You can buy those from AliExpress if it's cheaply. I think I've got an 11 tooth pinion on here, so it's slightly different gear ratio, different motor, but these are using the nickel metal hydride 4.8 volt for C-cell batteries. The only thing is there is some expense with the radio gear and things like that, but what I've done here is I've mounted the electronic speed control and the receiver just onto a little glass fibre plate, which has got 2 screws here, so you can undo those screws and then use the bullet terminals to disconnect the motor. You can buy cheap 540 motors on eBay. They're not a big expense, but if you're doing the project with a number of students, you really want to keep the prices down. So then I've got the servos. I'm actually using some old AM 40 megahertz and 27 megahertz radio transmitters and receivers just to keep the prices down. With this one, I've been prototyping different versions as well. So I wanted to have one with this front end from the V12, which has got sprung upright, so it's got a little bit of suspension, a little bit of movement in there. And what I did is when I kind of revisited this, because we've got a redevelopment of work in the school design technology workshop, so we've got a bit more space to run a bit more interesting sort of projects and things like that. Yeah, so I realised that there wasn't as much support in terms of suppliers providing bits for the original Mardave Ministock, which has sadly been discontinued. Mardave do have spares for that available, but they're in short supply, and I didn't want to gear this up to find that I can't buy the wheels or can't buy the hubs, or there's some particular part I can't get. Obviously you can 3D print a lot of the parts in-house, but we've only got quite a cheap 3D printer. It works when it wants to, but you wouldn't want to have to make large numbers of the same part. It's all right for a demonstration, so you could easily do a few cars just with the wheels and gears and things like that. But then, yeah, if you can buy the parts for a few pounds each, it's probably worth buying some of those bits in and then just using a 3D printer for a few sort of demonstrations as well. Just so students have got an awareness of how it works and the CAD software. And then if a particular student wants to design their own kind of custom sort of wheel inserts or wheel rims or whatever, then they could do those, and that'd be quite a nice extension for the project. But I didn't want to be really bogging down by the 3D printer with a big bottleneck with all the students waiting for, I don't know, 4 wheels, 4 lots of pinions and things like that. So it's yeah, I mean, you can even ball joints and rod ends and things like that, you could machine those. If you had a CNC lathe, you could make those quite straightforward. But they're cheap enough to buy in. But even though when you're buying in all the little bits, it does add up. And unfortunately, companies like Camtech do sort of support these projects, but it's really the third-party parts that they have to buy in, like the motors, the pinion gears, the sort of track rod ends and stuff, which they don't make a big markup on anyway. So I'm not saying that they make a big markup on anyway. When you look at the cost of their kits, they're terrifically good value. But if you want to do this with a number of students, you can't be spending the kind of list prices for these sort of kits and parts. So I think it's quite good. So I've got about 3 or 4 of the radio transmitters set up. I've got to get another battery, which they're cheap anyway. And I've got the battery chargers and slow chargers, trickle chargers and fast chargers for this. But the idea with that is it gives a little bit of development from the original sort of Mardave, which is super crude, super easy, very, very straightforward. But this has just got another little level of sort of not necessarily complexity, but it just gives you a bit more options in terms of tuning and handling and how you tweak this and get the best sort of handling. You can change the ride heights. You can put inserts and 3D printed inserts to give a little bit of caster angle. There's some camber adjustment just by having a shorter sort of front brace on there, so you can actually physically bend the wishbones up to give you a bit of camber. What else have I got on here? A little bit of turning in terms of aluminium spacers and things like that. I think I've got some spacers under here, so I can tweak the ride height, or as I said, you can put a wedge-shaped spacer underneath the lower wishbone there, which gives you the sort of caster angle as well. So yeah, it's just sort of moving towards a little bit more tunability. So that's that version, and then this version here, which is kind of just working on this. This was based on one of the Camtech mini kits, which has the sprung pod as per the sort of V12, and it's got the same front end as the car I just showed you. What I've done here is I've used a CNC milling machine just to machine the wishbones here. You can see the blue anodized spacer that adjusts the ride height here. And you've got a bit of springing on there, carbon fibre again, and then underneath there, that's just a sort of shim here, the black part there. I think that's laser cut, but it just allows you to adapt the ride height as well. On this one, I'm just using the fiberglass because it was just what I had available, and you can see there's loads and loads of chassis flex in here. I think with the weight of the battery, it's really going to kind of dip down. There's no top plate to brace the chassis. But what I'm doing on this one, I think this has the actual Schumacher differential as well. So there's a little bit more expense involved, but even the differential, you could actually machine one of those yourself. So it wouldn't be a huge job. And I quite like looking at off-the-shelf solutions, and you can kind of adapt that and sort of think, oh, how could we replicate something like that in-house? Well, maybe make it a little bit simpler. So this one I'm using 7mm Delrin to make the motor pod sides. The axle, I bought that in, it's a Schumacher one, but I think Mardave do a differential which is a little bit simpler than that, which could be easily made on a manual lathe if you're just making small numbers of those. I've got the aluminium upstands here, so I can mount the radio plate with the electronics onto here, so you can swap between the two. The only thing is on this one, I've got the Schumacher ball joint here, and I wasn't sure how Mardave did that when they're using carbon fibre for the pod, so I just made a little CNC carbon fibre retaining plate for that bearing part, so it holds it in that little ball socket there. So this is quite nice. This has got ball bearings on the front axle as well, so it just gives you a nice smooth rolling, cuts down the rolling resistance, and it makes it a little bit more hard wearing. Kimbra Servo Saver has got 3mm holes have been enlarged, so it takes the little bit more rugged steering arms there with ball joints. So what I wanted to do with this one, I've made the holes on the base universal, so you can switch in the original Mardave Ministock solid front end, which uses these holes here, so it bolts through. And then I've got the original Mardave type sort of bumper as well. And on the rear end I've got these holes here which pick up on the motor sides for this type of arrangement as per the original Mini as well. So what I wanted to do is have a chassis where you can switch out parts, you can get some lap times, you can sort of see what the differences are, and then it just gives you a chance to kind of compare and contrast and see what effect of maybe changing the chassis for carbon fibre or glass reinforced plastic or whatever. So yeah, the other thing, just this morning I was thinking about making these motor pod sides out of laser cut acrylic, which it doesn't have the impact resistance of the Delrin or the acetal, which is like a sort of almost like a nylon. It's a nice engineering plastic. It's nice and free machining, and it gives you a nice quality, lovely waxy smooth finish when it's been finished being milled. It looks really professional. It looks like you just bought these parts in, but it can be manufactured in school on fairly affordable equipment. Really, a lot of this stuff you could even make by hand. So you can make patterns, you could route round the patterns, and then you could have a template or jig to drill the holes through. And for the sort of counter bores and things, you could make a secondary route template. You could just route those to whatever depth you need. So that would be quite nice, because then it's teaching different hand tool uses and power tool uses and jigs and fixtures and templates and pattern routing and things like that as well. The chassis is that can be made by hand, so you can just carefully mark that out, a piece of aluminium sheet or glass fibre, and then you can just drill that on a pillar drill. Alternatively, you could use one of these as a template, and then you can spot drill through the holes, so that gives you the nice precise spacing to get everything square and 90 degrees. What I've got on here, I'm not sure how many of these holes. I think I've copied some of these holes over from the Camtech kit. So these are the holes for the body mountings, and I've got extra holes for various bumpers and things. And then I've got those holes which are transferable from the original Mini kind of chassis as well. The holes for the battery pod, because I wasn't sure how much extra material I need, because I'm using this ball here, so that's encroached a little bit on that hole. So all I've got to do on this one is just drill an extra couple of holes so I can move the battery pod or the battery tray a little bit further forward. But that's obviously, I mean, this is a prototype, so it's only a little bit of fiberglass you're using just to try that out. And this is just a stock 540 motor. I think that's actually reclaimed from an old CNC spindle, so I don't know what the sort of RPMs are, but you could easily test that as well. So yeah, quite a nice project. This one here, just a version. I think this is actually this is like the Camtech sort of chassis. So on this one, I didn't have the additional holes for swapping out the original Mardave Ministock beam as well. And on this one, I'm just using 6mm acrylic for the bumpers. Unfortunately, acrylic doesn't have a lot of impact resistance, so it's not the ideal material. But there's a supplier that laser cuts material, and I can pick up offcuts of polycarbonate and acrylic from them. I just wanted to use that because it can be laser cut, so it gives you a chance to prototype parts, and you can make them really quite fast. With this one as well, I was thinking of using the same 6mm acrylic to make the motor pod sides. So these ones here, these have been routed on a CNC milling machine just out of the acetal. But I think if I make those out of the 6mm acrylic, it wouldn't be rigid enough to take the drilled and tapped holes in the base to mount that on. But what I thought I could do is actually make some sort of spacers and then bolt through maybe a little piece of aluminium rod, just drilled and tapped, so I could just bolt those together. So I'd actually have that as like a little self-contained pod, and then it'd be fairly easy. Just use a piece of square aluminium bar, just drill some holes and tap into the aluminium, and then bolt that on. But obviously I'd have to look at the clearances where the motor is and where the axles go, and see if that infringes on the spacing for the springs and things. So I might have to go back to the drawing board a little bit for that one. On this one as well, I noticed that Camtech have changed the design of the battery tray. So I think they've got additional holes in the end, which has sort of got a clearance there, so the battery sits over the top of those. So what I might do is make some of these modified chassis just with a few additional holes for making the additional battery mounting positions and things like that. But obviously on this one, most of the work's done in terms of getting a running car, so I'll just have to mark out by hand and just drill through the additional holes and move these further forward so I can fit in the battery tray in here without this part here fouling on that pod there. Alternatively, fit it that way, these bolts will limit the amount of travel on the rear pod. In terms of reducing the number of purchased bought-in parts, I'm just using the aluminium turned sort of washers here. These have got a sort of a step on them, and it just locates in the end of the spring here. And then this part here, which just contains a little O-ring, was just made on a CNC machine. So it's a really nice project, and lends itself to lots of development. Obviously the bodywork is going to be a major hurdle in terms of how you actually manufacture those, but it's vacuum formed from ABS, so once you've got a former you can reproduce these in seconds, so they're easy to make. ABS is a little bit tough to cut the windows out, so it might be better going for polycarbonate, but unfortunately polycarbonate absorbs moisture, so you actually have to dry that out before you vacuum form. The bodyworks are very cheap, but obviously you could even use high impact polystyrene, which wouldn't be as strong as the ABS, but then you can mold those in sort of self-color plastic as well, so you get some nice colorful cars pretty quickly. Looking to make a former using a CNC router to layer those out from different thicknesses of MDF or chemical wood, and then make the original vacuum forming pattern, so I can reproduce a number of the bodyworks just to have something to kind of get up and run straight out of the box. So there's just trying to do this one hand is not going to be easy. Saying that, it's quite easy. Yeah, so there's a finished car with the body on it, on the electrics all ready to go, and then you just got the body pins that go through these holes. It's probably not very entertaining watching someone do this on the line. We've all seen how these mount before. You're not going to learn anything new. Yeah, so that's just a white ABS, self-coloured ABS, but yeah, quite a nice little car. All I've done on this one, in comparison to the British Racing Green painted one, I've got clearance on the wheel arches, just so you've got the springing on there. This is quite stiff at the moment, so you can swap the springs over. The rear end is allowing for the travel on the pod, but the ride height on this one is really high, but I don't mind that. It's just a kind of test bed really. And what I was going to do, I've got an order on AliExpress for some LED reflectors and lenses. The little module fits in there, so once those come, I'll just open up the headlights and fit those in, so you can have LED lighting on the front. The rear end as well, it's just got moulded in lights, but you could even have just a couple of LEDs, a couple of red LEDs and a amber LED with indicators and things on it like that, just to add a little bit more interest. The window surrounds, I've final cut these, so I put the stickers on. I had the window itself as a separate part, so I could peel that out, and then I could just work with a Dremel with a small little sanding drum just to square these up nicely with a nice radius on there for the window openings. Alternatively, you could just use the vinyl cut stickers and you don't need to cut the windows out, but I think it just makes it look a bit more finished and a bit more like a proper car with the windows cut out. Yeah, so apart from dropping the phone, I think it's quite an interesting little video there. Really encourage use of this project, and if you're in a school with limited amount of equipment, then it would be nice to use some of the Facebook groups and things like that to see what other schools are interested in this project as well, and then perhaps they could help support you by possibly laser cutting some of the parts, keep the costs down, and maybe share resources and files that way. So this is, or what used to be, the Mardave or the Formula Schools competition, but just doing this as an in-house club really. Yeah, it's a fantastic design. It's really creative. A little bit of spray paint. The cars can look really eye-catching. It can look really professional. And also, when the school is doing open evenings and things like that, you can show really inspiring projects as well, which really get the students enthused and really get them wanting to choose the subject as an option. And I think projects like this, they lend themselves to that inquiring sort of frame of mind in terms of what can I do to improve it? How can I go faster? How can I make this better? How can I make it stronger? How can I make it lighter? And obviously, then you've got lap timing through mobile phone apps as well to give you that data, so you can sort of think, okay, I put a differential on here, my lap time went down 1.5 seconds, so that's a clear improvement. Or I changed the pinion gear and that was actually slower, or I changed the motor and that wasn't as fast as I hoped it to be. Where was I losing speed? And you can even get results through Arduino microcontrollers and set up timing gates, and you can even have split times on a lap. So you can really take this to quite a sort of advanced level of sort of performance, analysing the data as well. And I think that's quite good in terms of looking into other kind of projects and forming schools. And you've got F1 in schools as well, and then I think there's the eco schools so yeah, it's just having that interest and enthusiasm for engineering and testing and research and development as well. Obviously, with the speed controls, the higher end speed controls have got you can program those, and you can look at the sort of throttle curve and things like that as well. So that will really add a whole new level of interest and give you the option to really sort of tweak and develop the concept and the design as well. Yeah, so I do like the Mardave company. Obviously, with AliExpress and the Chinese producers of radio control cars, you can buy things really cheaply and almost like throw away. But Mardave is I don't know if it's just a sort of vintage interest that I've got in the sort of the kind of retro sort of aspect, and it's very 1970s. It's quite good. It's like the early days of RC, but I think once you throw a little bit of carbon fibre at these things, they do look quite fun. They do look quite sort of like a little mini racing car. And with the new parts, you can change rims. You can change the colour of the rims as well. And you can really sort of hop them up and make them like little custom little hot rods really. But yeah, starting off from the pretty basics and then looking at something a little bit more advanced and almost like a secondary class as well. But I think with these cars as well, they do run on carpet. They don't run outdoors. They're not off-road buggies, so you do need a nice smooth carpeted surface. But schools, sixth form common rooms and halls have got the space, so you can run them in school. And I think you can even look in at rubber tyres and things for these to give them a bit more flexibility in terms of what you can run them on. So yeah, they're really nice little project, and bodywork's like £6 to buy, so you can buy a few of those, and then the students could cut the windows out, cut the wheel arches out, use a little drum sander on a drill to cut the arches out nice and neatly, make some templates of the windows so they can cut those out, and you can even just cut the front ones out, the windscreen out, and just have the back as a little van or whatever. And then you've got the 2D design software for designing all the graphics and the vinyls and the checkerboard roofs and the Cooper stripes on the bonnets and things like that, racing numbers. So yeah, I think with a little bit of variable options in terms of wheels and colours and choices, and the white roof or the black roof and a white car, and yeah, it can really make them really unique and really eye-catching. And it's a great project as well for the sort of school newsletter as well to get interested in the subject. I think a lot of parents will be at the age where they might have had radio control cars when they were kids as well, so it might have a little bit of interest. And moving forward in terms of inter-school competitions and running this as a competition, I think it'd be quite nice to seek even sponsorship from local businesses and things like laser cutters and suppliers and garages as well. So you could ask them if you could use their their logos and things like that, and if they'd support in terms of materials as well, because they'll obviously be featured in school newsletters as well. And I think it's a nice community sort of project as well. One of the things I've become a little bit more interested in through the whole lockdown is, I think when everyone was quite isolated, it's just trying to develop things with sort of companion schools and things like that. So if there's a school where they don't have a particular piece of equipment, if you can share the ideas and resources and develop things more as a community rather than just each school working in isolation. I don't have, it's not my design now. I'm using parts inspired by Mardave and Camtech, so I'm not selling these. I'm just selling the idea really. But I mean, it's just a can of Halford's British Racing Green metallic paint. I think it's a Rover colour. It just looks really good. So hopefully, I don't know, I'll just share the few ideas and just trying to get more interest really. I think there's a few schools that I know that might be interested in this, but once you can demonstrate something and you can cost it in terms of what's made in site and what parts you have to buy in, then it's easier to convince senior management that this has got some worth as well, as opposed to just a technician wanting to race cars around the workshop. Isn't it? Camtech.